Okay everyone, this is section 8.4. In this section our goal here is to be able to multiply and divide rational expressions. Some vocabulary. A rational expression is in simplified form in which the numerator and denominator have no common factors. So for example, if I have AC over B times C, we have that C is in the numerator and denominator, so they can actually cancel out and we're going to be left with A over B. And in this next example, we have this rational expression, and we both have a factor of x plus 3 in the numerator and denominator, so that they can both cancel out as well. So this is just simplified as 4 over x minus 5. So if you have a factor in both the numerator and denominator, they can actually cancel out. So in example 1 here, we don't have anything to cancel out quite yet, but we can first factor the numerator and denominator. So if I factor the top, or the numerator, again, if we want to do it the x method way, I'm going to put negative 15 up top here and negative 2 in the bottom. And if I have factors of 15 that add to 2, okay, 3 and 5 do work. So I'm going to use those. But in order to have a negative 15 and add to negative 2, I'm going to have to make the 5 negative. So here's going to be our new factors, x plus 3 and x minus 5. That's just what it factored to. So there's our new numerator. And in the bottom, or the denominator, we have a difference of squares that we've seen before. So this is the same thing as x squared minus 3 squared. So here's our a and b. So we're going to have two factors, a positive and a negative form of x plus 3 and x minus 3. Okay, so now if we check to see, after we build our factors here, I have an x plus 3 in the numerator and denominator, so they can both cancel out. So we're going to be left with x minus 5 over x minus 3, and they can't cancel out or do anything else, so here's my simplified form of that rational expression. So when we multiply rational expressions, we're just following the same property as we would for normal fractions. So in middle school, you probably learned to multiply fractions just numerator with numerator, or the tops together, and then the denominators together, or the bottom part of the fraction. So we're going to do the same thing here. We're going to multiply the numerators straight across and the denominators. So we're going to have 30 x to the third, y to the third, over 20 x, y to the third. And in order to cancel some stuff out, we can kind of break it apart. So 30 is just 10 times 3, and I have 3 x's up top and an x in the bottom, so I can only cancel out one x because that's what they have in common. So I'm going to split apart the x's here, so x and x squared, because I originally had 3. Okay. Then I'm going to split apart my y, but they both have 3's, so I'm just going to keep it as y third. Okay, so there's the new numerator. Then if I break apart the denominator, I have 10 times 2 times an x, because I only have one of them, and 3 y's. So from there, I can cancel out the 10's, I can cancel out one of the x's, and the y cubes. Okay, so after that, we're just going to be left with 3x squared in the numerator, all over 2. And that is our simplified rational expression after multiplying those two together. In example 2, we're going to do the same stuff. So first, multiply the numerators together and the denominators. So 8 times 7 is 56. And then we're going to have 7 x's up top and 4 y's. And in the denominator, 2 times 4 is 8. I have 1x and 3 y's. So if we kind of break this one apart, well, let's see an 8 in the denominator, and 8 is a factor of 56. So I'm going to break apart 56 using a factor of 8 and 7 again. And if I compare my x's with the denominator, well, I only have one x in the bottom, so I could only pull one x out. So I'm going to be left with 6 up top. And in the denominator, I only have 3 y's, and in the numerator, I have 4. So I can pull out 3 of them to cancel out and be left with one of them. And then the bottom, I could still keep that an 8 so they can cancel out. And then the x, and then 3 y's. So if we go canceling some stuff out, the 8's can cancel, the x can cancel, and the y cubes can cancel out. So we're going to be left with 7 x to the 6th times y. And we could smash them all back together through multiplication. In example 3, before we go multiplying straight across, what we're going to do is factor some stuff if we need to, and kind of factor by grouping or pull some stuff out first. So in the first numerator, I see that they both have 3's in them and an x. So let's pull out the 3 and an x, so that we're left with 1 minus an x. Okay, and in the denominator of that one, we could actually factor that. So this can be factored, and if I think of factors of 5, only 1 and 4 work, or 1 and 5 work, sorry. And I'm going to use those, but I need the negative to be on the 1 because we needed to make a positive 4. Okay, so in the bottom, my factors are x minus 1 and x plus 5. So there's a new factored out rational expression there. And we're still going to multiply by the factored version of the top, so let's factor that one out. Negative 20, and a 1 in this case, because it's in front of x right now. So my factors of 20, 4, and 5 actually are going to work. But I need the negative to be on the 4 in order to make a positive 1. So on the top, this is x minus 4 and x plus 5. And in the bottom, I can't really pull anything out, so this is just 3x. All right. So now, if we multiply straight across in the numerator and denominator, we're just going to put a lot of stuff together. So this is 3x, 1 minus x, x minus 4, and x plus 5. And in the bottom, we got 3x again, x minus 1, and x plus 5. Okay, so right now, I could see a lot of stuff canceling, but I see this kind of x minus 1 and 1 minus x going on there. I'm going to rewrite them so that they're the same and I can cancel them out completely because they're not really the same thing right now. Okay, so what I'm going to do is pull the numerator out a second. I'm going to rewrite it. Okay, and I'm going to rewrite it to make it look like x minus 1. And how I could do that is pull a negative 1 out of it. Okay, so this will be 3x, and I'm pulling a negative 1 out to make it x minus 1. And you can check yourself too, because if I distribute the negative 1 back to it, I'm going to have a negative x and a positive 1, which is what we just started with there. Okay, then I'm going to have x minus 4 still there, and x plus 5 all over 3x, x minus 1, and x plus 5. Okay, so now we can go cancel some stuff out. So the 3x can go away, x minus 1's go away now, and the x plus 5's. So we're left with a negative 1 up top, nothing in the bottom, and I still had up top in the numerator x minus 4. But if we distribute that back to it, because it's just a constant, that is negative x plus 4, because two negatives made a positive. So out of all that, I'm just ending up with negative x plus 4. Okay, in example 4, same stuff. I'm going to multiply. Okay, so still multiplying straight across, but in that second rational expression, it's not yet irrational because I don't have the fraction bar. So I'm just going to put it over 1 so that it does create a fraction. Okay, so up top, I'm still going to be left with x plus 2 and the one up top is not factorable, so I'm just going to leave it alone. If you try to do the x method on it, it won't work. No factors of 9 can add to 3. And then the bottom, I just got x cubed minus 27 times 1, which is still itself, but this x to the third power minus 27, this is a sum, or actually a difference of cubes. And this was talked about back in chapter 5 when we did a lot about factoring polynomials. Okay, we had a formula for that. So if it was a difference of 2 cubes, we basically took a minus b times a squared plus ab plus b squared. And in this case, a is x, and 3 is going to be b, because 3 to the third power is 27. So this is going to factor to first a minus b, or x minus 3, and then a squared, or x squared, plus ab, or 3x, and plus b squared, or 3 squared, which is 9. And that makes sense because now that x squared plus 3x plus 9s, they go away, they cancel out. So we're just going to be left with x plus 2 all over x minus 3. So here's our simplified rational expression after multiplying these two. So we multiplied rational expressions, now we're going to divide rational expressions. Okay, so when we divide, we have one property. Basically, if we see two of them being divided by each other, what we're going to do is take the second rational expression and multiply by its reciprocal. And I spelled that wrong, so hold on. Okay. So if I take the reciprocal or flip it over, and that is still spelled wrong. Pro-cal. Oh my goodness. There we go. Alright, so basically we're just taking that second rational expression, flipping it over, the reciprocal, and still multiplying straight across. Okay, so again, you probably did this back in middle school. So if I want to divide these two fractions, I'm just going to keep the first one and multiply by the flip-flop, or the reciprocal of the second one. Okay, and I just multiply straight across, numerator with numerator, denominator with denominator. So this is 6/35, and that cannot be simplified down anymore. So we're going to do the same thing with expressions that are rational. Okay, so first we're going to divide these two rational expressions. So again, what we're going to have to do is multiply by the reciprocal of the second one. So I'm going to leave the first rational expression alone, or the same, and then multiply by the flip-flop, or reciprocal of the second one. And I know in that second one, I can pull out and make factors I can also pull out some stuff in x squared minus 6x. And also in the first rational expression, its denominator 2x minus 10, I could factor out a 2 out of both of those. So let's go ahead and do that. So 7x is okay, but if I pull out 2 out of both of those, I got x minus 5. Then in the numerator, the second one, if we do the factoring x method on that, factors of 30 are 5 and 6. That can make a negative 11 by both of them being negative. So this is x minus 5 over x minus 6, or times x minus 6, excuse me. Then if I pull an x out of the bottom, I'm left with x times x minus 6. Alright, and now what we're going to do is just smash them all together. So 7x, x minus 5 times x minus 6, and then the denominator 2, x minus 5, and x minus 6. Now let me go searching for anything I can cross out in the numerator and denominator. Well, 7 I do see an x though in both of them, and a factor of x minus 5, and a factor of x minus 6. So what I'm left with is 7 halves, or as a decimal, that is just 3.5. So it is okay and possible to just get a number back out of that simplified version of those two rational expressions. In our last example here, example 6, we're going to do the same stuff, okay? So, first, both of them aren't rational quite yet, so let me put that over 1. And we're going to multiply by the flip-flop, or the reciprocal. So I'm going to leave alone the numerator and denominator of the first rational expression. And multiply by the reciprocal. So 1 over 3x squared plus 5x. Okay. So again, I could see some stuff being factored out in the first numerator, and then the second rational expression's denominator I could pull out an x. So let's just factor first the first numerator. So my a isn't 1 anymore, it's now a 6. So first I have to think about 6 times negative 15, which is negative 90. And I'm trying to make a 1 in the bottom. So my factors of 90, I can make a 1, are 9 and 10. And I had to make the negative on the 9 to make a 1. And since my a isn't 1, I have to put a 6 on top. So 6x. And on both sides, they can be divided and simplified down. So 6x over 10, if I divide both of those by 2, I got 3x over 5. And then on the other side, if I divide both sides by 3, I got 2x over negative 3. So there's my two factors there. So 2x minus 3 times 3x plus 5, that just factored to that, all over 4x squared, we can't really do anything there, times 1 over, if we pull an x out, 3x plus 5. Alright, and now we're still just going to multiply straight across, numerator with numerator, denominator with denominator. So 2x minus 3 times 3x plus 5 times 1, that we don't have to write anymore, all over 4x squared times an x, and then 3x plus 5. And again, if we go trying to see if we can cancel some stuff out, if they're in the numerator and denominator, the 3x plus 5s cancel out, so we're left with 2x minus 3 all over 4x squared times x. But I can combine those x's. So that's 2x minus 3 all over 4x cubed, where 2x's plus another x makes it to the third power. So here's our simplified version of these two rational expressions being divided by each other.